Welcome. So in this short video I would like to talk to you about completing squares and zeros of quadratic functions. So these are two topics and they both are related of course to quadratic functions, where I give you a quadratic function in its general form ax squared plus bx plus c right here. Now the completing squares idea is an idea to rewrite the function here in a different form so that you can see lots of geometric properties such as a horizontal shift, a vertical shift, or the vertex, which is the minimum or the maximum of the parabola. Now to do this, I do on this slide actually very mathematical, and then later on I will show you a whole bunch of examples so that we can train this method. So to modify the equation, I factor out a factor a. So we have ax squared, so here I get an x squared. But then from the next term, this does not have an a. So I write this as b divided by a times x. And then I close the bracket, and I keep c untouched. So if you multiply this out, you get exactly what you had before. Now, this looks like making it more complicated, but I make it even more complicated, because now I'm ready to apply one of the binomial formulas, and I put this binomial formula here on the side. So I would like to use a formula, let's call it x plus d square. And you should be familiar with binomial formulas, so you know this is x squared plus 2xd plus d squared. And for the term x squared, so for this term here, wiggle, 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 plus b over ax, I would like to compare this to the first two terms here. And then you see this b over a plays a role of the 2d. So, which means I can write here x plus, so what is the term? B over 2a square, okay? But then I make a mistake. So if you multiply this out, you get x squared, and then you get 2 times b over 2a times x, which is this term. But then you also get plus b divided by 2a squared. And so we have to make up for this term by subtracting this term, right, like this. And then I have the closing brackets, so let me switch to my original color, plus c, and the c is untouched. So I made it even more complicated. And this might be like a stupid idea, but actually it isn't. So let me multiply in the a, so then we have a, x plus b divided by 2a squared. And then we use the square on all these terms. So we have b squared divided by 4. And then here we get an a squared. We multiply with an a, so what we keep is 1a, no a squared, plus c. And now this is in fact the form I would like to have, even though it looks a bit more complicated. So I just write it as x plus p square plus q, and then it's pretty clear what p and q are, right? So then p is b divided by 2a, and q is everything else, so the c thing, minus b squared divided by 4a. So it looks a bit complicated, but this form actually is really nice, as I will show you in the next slide and also the next examples. So here is the formula I derived, so the green formula, same thing. And so what you can read from this formula is the point P turns out to be the vertex, so meaning the minimum or the maximum, and P is also a horizontal shift. And this is better explained in examples in a second. So horizontal shift by a value of minus P turns out to be, and Q is the vertical shift, shifting a parabola up or down. And then A is a scaling parameter, which tells you how wide the parabola is. But also, if it's positive, you have a concave up function. If it's negative, you have a concave down parabola. So concave up is something like this, concave down is something like this. And of course, this relates to the leading order term, which I talked about in a different video. So where did this ER go? Parameter. Good. So let's do some examples. It will be much clearer there. So in this example, I would like to do exactly the transformation I did before. X squared plus 6x, I would like to apply the binomial formula. So I have something like x squared plus 3 square, x plus 3 square. And now if I multiply this out, I have x squared plus 6x, so that's fine, and I get a plus 9, which I need to correct for, so minus 9 plus 4. The term is x plus 3 square minus 5. This is the completing squares form for this quadratic equation. Let's look at the meaning of all these shifts. So here in the next graph I plotted these functions. So what did I plot? Well, first of all, I started with the normal parabola x squared. So this is the brown curve. It touches at 0, it is the normal parabola. And then here I shifted down by minus 5 to get the green curve. So the green curve is x squared minus 5. So that is the vertical shift of minus 5. And then from here to here, I shifted by minus 3. So then the red curve is actually my curve which I'm looking for, f of x. And so it is shifted parabola, shifted down by minus 5, shifted to the left by minus 3, which are these numbers sitting right here. And you also notice that the minimum is sitting right here at minus 3, so the vertex of the parabola is exactly at this point. So that's the advantage of this form of completing squares. You can really see a lot about the geometry of your parabola. So, up for another example. A little bit more complicated. So, because we need to factor out this minus 3 in front of x squared, and we keep x squared. Now 6 is divisible by 3, that makes it a little bit easier. So we get minus 2x. Note the minus sign if you multiply it out. And then we keep the 18 untouched. And then we complete squares inside here. And this worked pretty nice with red earlier. So I write this as x minus 1 square. Again, in your head, x squared is here, minus 2x is here, plus 1 is not here, so we need to make up with a minus 1. And then we have the plus 18 and the closing bracket as well. So then this together is minus 3x minus 1 square. Now I multiply the minus 3 to the minus 1, which is a plus 3 plus 18 is plus 21. So this is the completing square version of the previous function. Let's look at the curves here. Here we start with the curve minus 3x squared. I move it up to the green curve with a shift of plus 21. And then I shift it over to the right with a shift of plus 1 as a horizontal shift. So here is a shift to the right and here is a shift upwards. And the 3 is a scaling factor. So I think makes complete sense. Now let's look at the other topic, which is zeros of quadratic functions. Yeah, when is a function equal to 0? And I call it the midnight formula because every dog should remember this formula in its sleep. And so here we go. This is the formula. So we have two zeros. I told you at some point earlier that quadratic functions can have 0, 1, or 2 zeros. So in the general case, we assume 2. And then they are given by this formula where the coefficients a, b, and c come from the equation. And they are just substituted here. So minus b plus minus root of b squared minus 4ac divided by 2a. And this term b squared minus 4ac has a special name. So let's go back to the two examples which I had earlier. So x squared plus 6x plus 4. Let's rewrite the midnight formula, the formula for the zeros. And I also plot the function down here for our convenience. And just sub in the numbers. So just do it. So b is 6, so we have minus 6. Then we get this plus minus and a long root. So b is still 6, so the square is 36. Minus 4ac, so a is 1, c is 4, so we get minus 16. Divided by 2a, a is 1, so we have only divided by 2. So the first term then is minus 3. And then we get plus minus 1/2 root of, and this is 20. Now 20 is, of course, 4 times 5, and 4 has a square root, so I can write this as minus 3 plus or minus root of 5. And now, if you plug this into the calculator, you get minus 0.76 if you use a plus sign, and you get minus 5.23 if you use a minus sign. And let's see where these values are. So minus 0.76 is about here. And minus 5.23 is about here. So this is exactly the zeros of this function here. Let's do the other example. Again, I just remember this formula, which I know so well, and I plug in the numbers b's, a's, and c's. So let's get started with this. So we have minus 6 plus or minus root of 36. Now for AC, so now A is minus 3, and with the minus sign here we get a plus sign. Times 4 is 12, and then the C is 18, so I write this maybe as 12 times 18 to just show the terms. Divided by 2a, a is minus 3, so it's divided by minus 6. And now again, it is just a matter of simplifying this expression, which I shortcut. And then again, you can find these values exactly here in the graph, as described before. Okay, so what did we learn from here? So completing squares gives you a lot of information about the geometry, so the vertical and the horizontal shifts of a parabola, the midnight formula for the zeros of quadratic functions, and it should be known by everybody.